This is video homework for Tim Barron, Physics 229, Strength and Elasticity of Materials, problem 3.3-3. What we have here is somebody is removing a wheel to change a tire, and the driver applies a force at the two ends of the arms of the lug wrench. What they want us to do here is determine the maximum shear stress in the arm that is turning the lug nut and determine the angle of twist in degrees of the same arm. We're given that P equals 25 at the ends of the two arms of the lug wrench, and that the steel has a shear modulus of elasticity of 11.4 times 10 to the 6 psi. Each arm of the wrench is 9 inches in length, and the solid circular cross-section diameter is 0.5 inches. To solve this problem, we're first going to have to solve for the torque, and then we're going to use formula 3-14 to solve for part A, and we're going to use formula 3-12 and 3-17 to solve for part B. For part A, to solve for maximum shear stress, first we're going to solve for the applied torque, which is P times 2 times L, and then we're going to use formula 3-14 to solve for the maximum shear stress, which is 16 times the applied torque over pi d to the third, giving us 18,335 pounds per inch squared. To solve for part B, the angle of twist, we're going to use equation 3-12 to solve for the polar moment of inertia, which is pi times d to the fourth over 32, and then we're going to use the angle of twist formula, equation 3-17, which is applied torque times length over shear modulus of elasticity times polar moment of inertia, giving us an angle of 3.32 degrees. In conclusion, we first solved for applied torque, then we used equations 3-12, 3-14, and 3-17 to solve for the max shear stress and angle of twist. It's amazing to note the amount of shear stress in the arm of the lug wrench to turn the lug nut.